Good evening. In previous session, we have seen some of the important methods that are used in our multi-threading. So let us briefly see about those methods we have seen in previous session. Those are first one, if you want to find the name of the thread, then we have to use a method called as get name. Get name. So if you want to set the name of a thread, then we have to use set name. Okay, get name and set name. And here we have to write the name of the thread. What we have to write here? Name we have to write. Okay. Instead of using this get name, we can also use name variable. Already we have seen one example for this one. Okay. For getting the name and setting the name, we are having the methods. First one is get name and second one is set name. Next, let us see next method, that is to find out the current thread. That means whatever the current thread that is executing currently. For that we are going to use a method called as current underscore thread. Okay, so it gives you what? It gives you currently executing thread. Next, if you want to get the identity number of any thread, then we can use a variable called as IDENT. Okay. Next, to see the active count of the thread, that means number of threads that are going to be executing currently. To see the count of that particular threads, we can go for a method called as active underscore count. Okay. Next, to see the information of these actively executing threads, we have to use a method called as enumerate. Okay, enumerate function we have to use. Next, to see the threads which are alive, I can use is alive, but it is a deprecated method. So we can also use is underscore alive. Okay, right? These methods we can use. So, and also one important method we have seen, that is join method. So join method is very important. So when we have to apply a join method is used when one thread want to wait until the execution of another thread, then we have to use the concept of join method. Okay. Next concept what we have seen in previous session, that is daemon threads. So what is meant by daemon thread? Daemon thread is nothing but a background thread which is executing in background. So the threads which are executing in background are called as daemon threads. So what is the main use of this daemon thread? The main use of this daemon thread is to support foreground threads. To support foreground threads. What is meant by foreground threads? Threads that are going to be executed in our program, for example. Okay, to support foreground threads. So by default we are having one thread called as main thread. I can consider this main thread as a foreground thread. For example of this daemon thread, what can I give? Garbage collector I can take. Garbage collector. So why we are going to execute garbage collector internally? Because to allocate the memory for the objects, we are going to internally one thread is going to be executed, that is called as garbage collector. So why it is going to be executed? To support the foreground threads. Okay, right. So here we are going to use two methods. One is for checking whether the given thread is daemon or not. For that we are going to use is daemon. So is daemon is a method which tells whether the given thread is daemon or not. We can also use a variable called as daemon. Okay, so here the nature will be there, whether it is a daemon or not. If it is a daemon, in this variable we are going to have true. If it is not non-daemon, in this we are going to have false. Next, if you want to set a daemon, if you want to set a thread as a daemon thread, I can use a method called as set daemon. So if you are going to use set daemon method, we can set the nature of a non-daemon thread to daemon thread. But here one rule is there. When we can set the nature of a non-daemon thread to daemon thread means, if the thread is before going to start the thread, then only we can set the nature, change the nature of the daemon. That means, for example, I have created one thread. For example, here I am writing some target. And before starting, if I want to change the daemon nature, I can change it. There is no problem, because here the thread is not started. After that, I can start. So now it becomes what? It becomes daemon thread. So before this, if I write t dot start, now what happens? We are going to get an error, because before going to start the thread only, we can change the nature of a daemon thread. Okay, so this is not possible. This is possible, because after changing the nature of a daemon thread only, I am going to start the thread. Next, we cannot change the nature of main thread. By default, main thread is which type of thread? Non-daemon thread. Okay, non-daemon thread. Non-daemon thread. So can I change the nature of this main thread? No, it is not possible, because whenever we are starting the execution of a program, already main thread will be started. If the main thread is going to be started, how can we change the nature of that main thread? It is not possible. So we cannot change the nature of the main thread. So what is the when the daemon threads are going to be terminated? If there is no foreground threads, that is nothing but if there is no non-daemon threads executing in your program, then automatically daemon threads will be terminated. Okay, so this is about daemon threads and few methods we have seen in our previous session. So in today's session, we are going to see very important concept in multi-threading, that is synchronization. So this is very important concept of multi-threading, right? Now, before going to see, okay, the concept name is what? Synchronization. Okay, so what is meant by synchronization? I before going to discuss this synchronization, I will go for the concept of before whatever we have seen about multi-threading. I will show you one small example. So if I previously I have executed the same program I will demonstrate to you, because if you see the problem whatever we have faced in the previous programs, so to overcome those, I am going for the concept of synchronization. If you understand the problem, so it is easy to understand what is meant by synchronization. Okay, just I will write a small program to demonstrate the problem that we have faced whenever we are performing the concept of multi-threading. So I will create a thread from threading. Already we know the module is called as what? Threading. From this, I am going to import all the components or all the classes and functions of that particular threading module. Just I want to define one method for what? For displaying or for printing some content. Here, for I in range of, I want to write I in range of some 5 I am going to take. Here just I want to print what? I want to print a child thread. Child thread I am going to print. So this is my function. So I will write my main code here. That is, I am going to create a thread. So what is my target? Target equal to show. So target equal to show. Am I having any parameters? I am not having any parameters, so that no need of writing args here. Next. So now I am going to start thread. That means what? From this statement onwards, a new thread is going to be created and it starts the execution of this target. If you are not going to give any target here, remember this point, it will search for a run. But here I have given a target. So if I'm not giving any target, by default, it will search for a run method. So as I'm giving some target here, so when I'm going to start a thread, it will search for the target, that is show. So child thread will go here and it starts executing this show method. Then what main method will do here? So I will give the, main thread will do here. I will give some task to be performed by the main thread also. That is same here, as child thread is going to print 5 times child thread. Here main thread is also printing main thread 5 times. So main thread I am going to print. Now observe this program, right? So if you see this program, what will be the output of this program? The output of this program will be, I can't expect, but here what it is printing child thread, main thread. But if once I Once again I will execute. Once again I will execute. I will execute 5 to 6 times so that you can understand the difference. See here. Once it prints what? Child thread, main thread, and so on. Again, what happens? Main thread, child thread. Can I expect the output here? See here. Again, it prints what? Child thread, main thread. So see, here the output will be different. Output is different. That means what? Here I can't expect the output. The output is what? Irregular, or we can say the output is inconsistent. Inconsistent data is going to be present here. It is not consistent. See here. See what is the output here? We got main thread, child thread. Here I got what? Child thread, main thread, and so on. But here I got some different output here. That means it is not a consistent output. So here, without here, this is a problem we are facing with the multi-threading concept. So to overcome this problem, I am going for the concept of synchronization. That means what? Till now, both threads are going to execute simultaneously. Let us take these two are threads, for example. So if these two are executing simultaneously, then what happens? It is doing its own task. Its task, and it is executing its own task. Now what happens? This thread is going to execute this function, this thread is going to execute this function simultaneously. So we are going to get irregular output. Now the task is here, if these two are executing the same task, for example, if these two threads are executing same task, then what happens? Then there is a need of synchronization. If there is no concept of synchronization, then we are going to get what? Data inconsistency problem. So before going to see these inconsistencies in all these terms, just I will give you a few real-time examples so that we can go into our concept. Okay, right. See here, for example, we are function is going on. We are having one function, that is a wedding function is going on. Okay, marriage function. So here, so after completing the marriage function, what happened? Few items are left. Okay, wasted. So that what they are going to do? They are going to keep one what we get banana leaf, and they are going to keep remaining food here. Whatever the food it is wasted, those are going to be placed on this banana leaf, and they kept for a dogs, for example. So here dog 1 is there, dog 2 is there, dog 3 is there, and dog 4 are there. 4 dogs came to eat this wasted rice or wasted biryani, for example. So here what they will do generally? So this dog will catch the banana leaf this side, and this dog will catch the banana leaf this side. In the same way, all dogs will catch the banana leaf at the same time, and they will drag. What happens if they drag this banana leaf? So if this dog is going to drag, this going to all dogs are going to drag the banana leaf same time. Then automatically this food is going to be what? This food is going to be wasted, because when they are going to drag this, pull this banana leaf, this food is going to be fell down on the ground in the mud, for example. So they will not eat if the food fall down on the fell down on the mud. So it is wasted. That means what? If all threads are going to execute at the same time, then what happens? Here the food is going to be wasted. In our concept, data is going to be inconsistent. Okay. Now one more example I will take. Okay. So general example is what? Synchronization reservation system, ticket reservation system, for example. So here what happens? This is a peak time. That is what bus tickets. We are booking a bus tickets in peak time. That is what Sankranti time. Okay, Sankranti time. I am going to book the tickets. So it's very peak time. So that what happens? Tickets will not be available. But I have, unfortunately, I have seen one ticket. I have seen one ticket here. So remaining all are filled. Remaining all are filled. I have seen only one ticket. So this is myself, and these are other people who are looking for the same tickets from Vijayawada to or Hyderabad to Vijayawada. Okay. Okay. In this route, the bus tickets are very. That means what? We cannot get the tickets at Sankranti time in this route. So that I have taken these routes, Hyderabad to Vijayawada. There is only one seat. Unfortunately, I found it. At the same time, these three people also found the same seat. So what happens? I thought that I am very lucky. So no one are seeing this, though no one has booked the seat. I have very fastly, I have taken my credit card and I am going to enter, and I have selected the seat. and I'm going to enter all my details, and I'm going to finish my transaction by using the by entering the credit card details also. So when I'm going to click on this OK button, what happens? Unfortunately, what they told me is your money was detected and ticket was not booked. I shocked at that time. What I will do? Automatically I will shock. Reason is what? Reason is I have done, when I'm seeing this one, what happens? Seat is available, and automatically when I click on this one, internally what happens? Internally everything is goes fine. Finally what happens? Ticket is not booked. Ticket is not booked. Then what is my what I will think here? So ticket is not booked, so that this bus operator is not good person, I will think. But actually what happens means, so when I'm going to select this one, this particular person also selected this seat, for example. So here there is no concept of, you can't observe the concept of synchronization. Now I will talk about synchronization. So if I am going to select this seat, otherwise, for example, so all can see the same type of data here. So as the seat is available, 4 people are going to see same type. That is what the seat is available in white color. They will see this one, so that seat is available, they can understand. But if one selected this one, what happens? That seat should not be visible for other people. Okay, then if he goes on this process, they will keep some time, 10 minutes time, for example. So until this 10 minutes time, no one should access this seat. So while filling this information, for example, this time is completed, then automatically the seat will be visible for all the other customers. That means what here? Before scenario, what happens? I am seeing this seat and all other people also seeing this seat. But while I am booking, I got this problem because here there is no concept of synchronization. But if this is the case, then what happens? My amount is detected and seat is not booked. It is not correct way. Then what is the correct way? When if I am going to select this seat, these 3 people should not see this seat. I have selected first, so they have to give the priority to me only. So now in this synchronization concept, what I am telling, if I am selecting this seat, then it should not be viewed by other people. So that what happens? They will give the time for me. Okay, in that 10 minutes I have to complete my task. Otherwise, let us consider I am taking some time because credit card details are not with me, so it is nearly 20 minutes over. So automatically after 10 minutes, what happens? This seat will be made available to all the people. So before getting these what can I say, credit card details, other people has booked this seat. Then automatically what happens? It will give you a message that take seat was not available for you. Reason is what? Because they have given some time to me, so I have not utilized that time, so the seat is available for other people. So see, here the concept what we have to understand is, here how many seats are there? There is only one seat which is accessed by multiple people. In our case, there is a code which is accessed by multiple threads. Then there is a need of synchronization. When multiple threads are going to access same, that is nothing but we can say it as a shared resource, then we need a concept of synchronization. If there is no concept of synchronization, we are going to get a problem called as inconsistency, or we can say data inconsistency. Data inconsistency. Okay, this is a problem with our if there is no concept of synchronization. So by using the concept of synchronization, we can overcome the problem of data inconsistency. Okay, better example I will tell you. So let us take here I value as 10. I value as 10. So here 2 threads are there. Thread 1 and thread 2 I am going to consider here. So if both threads are going to execute on this variable at the same time, so here, what is the task this T1 is going to perform is I plus plus, and task that is going to be performed by thread 2 is nothing but I minus minus. So generally, this concept is not there in our what we can say Python. Just I will write this I equal to I plus 1 because increment and decrement operators are not there in our Python. So I will take I equal to I plus 1 here. So if both are going to this particular I value at the same time, so if first this particular what this T2 is going to think as a result, according to T2 the result should be 9. according to T1, the result should be 11, because here I value is what? 10. So anyone can say that if I am going to increase the value of I by 1, the result will be 11 here. If by seeing this scenario, what I can think by seeing this statement, the result will be 9. But actually what happens, I will explain now. So see here, at the same time, both threads are trying to access on this one. Let us consider first T1 access this one. So automatically it is going to increment I value as what? 11. Now T2 came here. Okay. Now T2 access this value. Automatically the value of, if I value is decremented, what is the value here? 10. Is it correct value? What I require here? 9. What I got? 10. That means what? Data inconsistency here. Correct data, the output is not correct here. Okay. Same scenario, I will change the directions. That means what? Now, for example, I will take T2 came first. T2 came first when these two are coming to the coming to access this I value. T2 came first when compared to T1. Now what? It will become 9. So according to T2, the answer is correct. But now T1 comes here and it is going to increment I value. The answer will be what? 10. What should be the answer? 11. What is the answer? 10. That means what here? It is not a correct output we got. Correct answer we got. Reason is what? Because of multiple threads accessing the same variable at the same time. Then what happens? There is a problem of data inconsistency. Okay. So now what should I do? What should I do means, so I have to keep some restriction that, so if two threads want to access this one, then only one has to access at a time. I have to keep restriction that time, at any time. So what T1 will do? T1 will change the value as 11. Now if T2 goes here, what happens? It will see I value as 11. So if it is going to decrement, it knows that the value should be 10. There is no problem. But what happens if both are going to access this shared resource at the same time? There is a problem of data inconsistency. So this is the problem called as, if both are going to access the same shared resource at the same time, we are going to get a problem called as race condition. Both are racing. See here T1 and T2 are racing for change the value of this I. So those who are going to those are going to access I value first, those are going to win the race. Okay, so I will explain in detail about this race condition after completing this synchronization concept, because we have to see disadvantages also. We have to see this race condition also. So once we understand the concept of synchronization, by using the concept of synchronization, we can avoid the concept of race condition. Race condition should not be there. Okay, if you are going to have race condition, then automatically you are going to get what? Data inconsistency. Okay, right. Now this is about basic example, real-time examples of our, what we can say, synchronization, where we are going to use synchronization. Synchronization can be used in reservation systems. Okay, reservation systems. And also we can take one small example, that is joint account. If you are having a joint account, for example, you are having one ATM card, other two persons are the joint account, first account holder, second account holder. So here in our joint account, there is 10,000 amount is there. So if first person want to, what I can say, withdraw 5,000, and second person also want to withdraw some other amount, that is 7,000. So if there is no concept of synchronization, let us see what is the scenario. And if there is a synchronization concept, what is the scenario? Let us see. So first, initially, I will say what? There is no concept of synchronization. Then tell me that, is there any restriction? Both can access the this particular account at the same time. So both can see what? Amount as 10,000. So he will get 5,000 and he will get 7,000. There is no problem. So totally how much amount they have withdrawn here? Total amount is 12,000 they have withdrawn. But what is the amount it is available? It is only 10,000. Is it correct? It is not correct. So what we have to do? We have to use the concept of synchronization here. So that what happens? If anyone trying to access this one first, for example, first account holder is trying to access this account first, so that the amount will be, the transaction, what happens here? It has to be locked. So he is going to enter the amount here. That means what? if this particular second person want to withdraw the amount, then it will not be done, because one is going to access this one. So what happens after entering the amount? After entering the amount, what it will check the amount once again here. It will check the amount. So it is 10,000. So while person one is going to withdraw, no other persons can access this account, because here we are going to use what? Write operation. That means what? Modify operation on this one. That means I am modifying this value. When I'm modifying this value, no one can involve here. Okay, so that he got the money. So when he is going to get money 5,000, update operation also will be done. Update operation will be done. Then only the next person can access this one. Okay, so in the concept of this banking also, we will use the concept of synchronization. Now let us go to our main concept in our Python. How this synchronization is going to be implemented, let us see now. So what is meant by synchronization? We have to understand first. Next let us go to our, already we have understood about this concept clearly. Just I will give you a small definition for the synchronization. That is, if multiple threads are executing simultaneously, okay, then there may be a chance of data inconsistency. So to overcome this problem, we are going for the concept of synchronization. Okay, now I will just show you a scenario where we are going to get inconsistency problem. But here what you can understand, the output is going to be, already I have shown you an example. Here I have not shown you the scenario of both threads are accessing same one. Here main thread is accessing this one and child thread is accessing this one. There is no problem here. But now I want to show you what? I want to show you a method, this show method. I will write here some name. I am going to write here. It has to print what? It has to print thread, and I will write its name. For example, thread Shiva, I will write here. Just I will write what? Thread Shiva, sorry, thread name I will write. So first, if I will create two threads here. So T1 and I am going to write T2. Okay, two threads I am going to create, and for both the threads, target is what? For both the threads, target is show only. Okay, right. Next, I will start T1 dot start, and here I will pass some parameters so that you can understand, you can differentiate the thread 1 and thread 2. So when we are going to pass parameters or arguments, I have to use args. So in which form we have to pass here? I have to pass in the form of, what is that? Tuple. So here I am passing only one argument, that is what? Shiva. In next, for the second one, I am going to pass argument as Ram. I will pass. Okay, right. Now, so I will start T1 and T2. I will start T1 and T2. So two threads are starting at the same time, and both are accessing what? Both are accessing this show method only. So what happens automatically? I can't expect the exact output. So observe once, you will get a clarity on this one. So see here, thread Shiva Ram, thread Shiva Ram, thread Ram. So that means what? Here I can't expect a consistent data here. So output is what? Inconsistency is there here. So to overcome this one, where I have to go, or what I have to use here? I have to use the concept of synchronization. Very important concept this is. I'm going to use the concept of synchronization. Right. How to avoid this one? Tell me now. By using a synchronization. So in synchronization, what happens? How I can avoid means. So in synchronization, the threads will be executed one by one. So we will make threads to execute one by one by using this concept of synchronization. So that automatically what happens? Inconsistency problem will be removed here. Because if the thread is going to execute one by, okay, if the threads are executing one by one here, that means if thread 1 is executing first and if thread 2 is executing second, then will there be any problem? There will be no problem. If thread 1 is executing first, we will get what? Thread Shiva, 5 times it is going to print. After completing thread Shiva, if we go to second thread, then will there be any problem? There will be no problem. So there will be no inconsistency if you are going to use the concept of what is that? Synchronization. There is no inconsistency problem. So right now in our Python, how to implement this synchronization, that is our concept now. So we can implement synchronization concept in our Python in 3 ways. How many ways? 3 ways. So in that first way is by using lock. Okay, lock class, and second one by using or lock, and third one by using a semaphore concept. Semaphore. So these are the three. In these 3 ways, we are going to implement the concept of synchronization. Okay. So that means what? Synchronization nothing but what? I will make the threads to execute one by one by using these 3 concepts. Okay. Anyway, first I will go to the concept of lock. So I think 3 ways are what? Lock, R lock, and semaphore. First I am going to use the concept of lock for implementing the synchronization concept in Python. So first, what is meant by lock, we have to understand. So before going to see the concept of this lock, I will just give you a real-time examples so that you can understand the concept of lock. So this is a trial room, for example. This is a trial room. So at a time, how many members can enter into this trial room? Only one has to enter into this one. So but here, if I make multiple persons to enter into this trial room, is it correct? It is not correct. So I have to make what? I have to make this trial room as a synchronized, or I have to use the concept of synchronization for this room, so that only one can enter at a time. What I am going to do generally means, before, if I am entering here, if I entered here, just I will lock this room. Just I will lock this room. If second person if he tries to enter this room, what happens? He can observe that it is locked. So he has to do what? He has to wait. At the same time, third person came to enter into this one. Already it is locked. What he has to do? He has to wait. If n number of people came to enter into this one, then automatically all people has to do what? All people has to wait here. Reason is what? This room is locked. If the room is locked, what happens? Only one has to enter. Here our concept is also same. We are going to use what? We are going to use the concept of lock. Whenever lock is applied, then only one has to execute that. So now, okay, I will tell you the scenario. First one person came here, and he, as this room is not locked, he will enter into this room and he will lock. First he has to apply what? He has to apply or acquire lock. He has to apply or acquire the lock. After that, he is going to use this trial room. After completing his task, what he is going to do again? He is going to open this lock, or we can say he is going to release this lock. First thing what he has to do? Okay, first thing what he has to do? He has to acquire the lock and he has to do some task. After completing his task, he has to use the concept, he has to open the lock. So this is the scenario what we are going to follow in our synchronization also. By using the lock also, we are using the same concept here. So once again, I'm going to repeat the concept. That is what? If a person is there who want to enter into the trial room, what he has to do? First, the trial room has to be opened. So if it is open, this person is going to enter into this trial room, and he is going to do what? He is going to lock that room. That means what? He is going to lock. Okay, after that, he is going to use that trial room. After completing that, again he has to what? He has to remove that, or he has to open that lock, or he has to release that lock, and he will come out. And if it is open, what are the other people will do? Again second person will enter into this one. So again he has to apply lock, and he has to use that, and while he is coming out, he has to remove that one or release that one. So first one is what? Acquire the lock. After that, execute or use that room, for example. After using that room, we have to use the concept of release that lock. If we are not going to remove open that lock or release that lock, other people cannot enter into that one. So compulsory we have to follow what? Acquire the lock, and we have to execute the task, and we have to release the lock. Okay, right. By this scenario, I think it is clear for you what is meant by a how we are going to implement the concept of synchronization by using lock. Okay, right. Now I am going to use a lock concept. Lock for what? For implementing the synchronization. So it is a most fundamental mechanism. What is that? It is the most fundamental mechanism for what? For a synchronization concept. So generally this lock concept or lock is provided by already we know. So for implementing the concept of this multi-threading, we are going for what? Which module? Threading module. In the same way, this lock is also available in a module called as threading. So threading is a module that is going to provide as a class called as lock. So before going to use a lock, first I have to create a lock. For creating a lock, I have to use a lock class. So in this way, I have to create a lock. Okay. Now lock is what? L is a lock. L is a lock type. So lock, only this object can acquire the lock, or we can say what? Hold this lock. Only this particular lock can be held by only one thread. This is a lock. L is a lock. So this can be held by how many people at a time? Only one. Only one can hold. Only one can hold this lock. Okay, at a time. That means what? How many people can enter into a room? Only one person can enter into a trial room. So he will be locked. He is going to use the lock. So that means what? We have to understand clearly that at a time only one can use the concept of lock, or one can hold the lock at a time. So after that, after holding a lock, what he will do? He will execute. After executing the task, he will come back. While he is coming out, what he has to do? He has to release the lock. So now observe. So L equal to lock. I have created a lock here. So to get this lock, I am going to use a method called as acquire. A method called as what? Acquire method. So lock class is going to contain mainly two methods. Okay, one is acquire, another one is what? Release methods. Mainly we are going to use these two methods of lock. Okay, so I'm going to create a lock by using a lock class object. I am going to create a lock by using a lock class, and first to get that lock, what I have to use? L dot acquire. If I write this statement, that means what? I'm going to acquire the lock. I means what? Thread is going to acquire the lock. Next, here some statements will be there. These statements will be executed, and after that, after completing those statements, I am going to release the lock by using a release method. Okay, now once again I'm explaining. First, to implement the concept of synchronization, I am using a lock. So to implement the synchronization concept by using the lock, first I have to create what? Lock object I have to create. So how many threads can acquire the lock at the same time? Only one. So let us consider, for acquiring the lock, we have to apply a method called as what? Acquire. So what is the need of acquiring this lock? Reason is, these are the statements which are synchronized. This is synchronized code. So, or we can say synchronized operations to be performed. So synchronized operation is nothing but what? These statements has to be executed one at a time. So one thread is going to acquire the lock, and it has entered into this region, and it is executing. At the same time, one more thread came to acquire this lock. Is it possible? It is not possible, because already one thread is executing internally. One person is already present here. Is it possible to enter into this one? No. In the same way here also, if one thread is executing these synchronized operations, or this is accessing this region, if one thread is accessing this region, no other thread can enter into this one, because to enter into this region, otherwise, first I will tell this one, to enter into this room, what we require? This lock. So in the same way, to enter into this area, we require the lock. Already this lock is acquired by whom? Other thread. So when this lock is available, when that particular thread is going to release that lock, it is available for other threads. That means what? After completing all these statements, the thread is going to release that lock. Then that lock can be used by other threads. This is the concept. Okay. So this is the concept of lock. So here we have to observe what? Two things. One is we have to create lock object first. After that we have to apply two methods. One is for acquiring the lock, or we can say to get the lock. What is the need of getting a lock? To execute the synchronized operations. Next, after executing all these synchronized operations, we have to release the lock. What is the need of releasing the lock? If you are unable to release the lock, other threads cannot enter into this one. Other threads cannot enter into the synchronized area. Okay. So this region is called as, I can call it as critical section. Critical section. What is meant by critical section? Means the code which is shared by many threads is called as critical section, and that critical section can execute only by one thread at a time. So we are calling this one as critical section. So if I say something as a critical section, that section has to be executed by one thread at a time, one at a time. Okay. So if one thread has to execute this one, I have to apply the concept of what? Synchronization. So I'm going to acquire the lock and entering into this region. Which region it is, or which section it is? Critical section. So this is what? Acquiring lock. After that, releasing lock will be there. In between, what we are having? Critical section. So critical section has to be executed only by one thread at a time. So now I am going to show you one example by using this lock concept. Okay. So when we are going for this lock concept, when there is a shared content is there, or whenever your program is going to contain some code which is shared by multiple threads, that means what? Which want to be accessed by multiple threads, then I have to do what? That code has to be synchronized, because if I'm not going to synchronize that code, automatically we are going to get what? Data inconsistency problem. So let us consider, here I'm going to create a lock. After creating a lock, I'm going to write one method called as define show method. A show function I'm going to write here. Here there is code we are having, normal code we are having, and some code is here which has to be synchronized, because this type of code should be executed one at a time. So what I have to do here, I have to acquire a lock. So here I have to acquire a lock, so that only one at a time will enter into this region. After completing, what we have to do, we have to release that lock. So after releasing that lock, also we are having different type of statements we can have. There is no problem. But this region is called as what? This region is called as what? Critical section. Okay, this region has to be entered only by one thread at a time. So to understand this scenario, just I will take our highway. So this is our highway from Hyderabad to Vijayawada, for example. So to go from Hyderabad to Vijayawada, nearly we will get 3 toll booths, for example. Okay, 3 toll booths we are going to get. I'm talking only about one toll booth now. So here, how many vehicles can move on this highway at the same time? Many number. Let us consider I'm taking 100 vehicles can move here, or 1000 vehicles, or any number of vehicles can move here. But there is only, in toll gate, there is only one entry is there. Now in this entry, at a time, how many can enter? Only one can enter. After one can enter here, see here, one particular vehicle is going to enter into this one. After it is coming out of this loop, out of this toll booth, then only second one can enter. If this one is going to, so just I will give you a clear scenario. So see here, this is a toll gate. While one vehicle is entering into toll booth, here it will be locked. It will be locked here. So second vehicle cannot enter here. So if this particular first vehicle leaves out of this toll booth, then automatically these are going to be opened. Then only second person can enter into this one. In the same way, here if you are going to acquire the lock, only if you are going to write L dot acquire, only one thread can enter into this region. After it releases the lock, then only others can enter into that particular area or particular code. Right. This is about synchronization by using lock concept. Now, just I will change the code what I have, what we have seen before. Observe carefully here. Same code I am going to demonstrate. Here I want to do what? I want to make one by one. First thread 1 want to execute, second thread 2 want to execute. In this way I want to modify the program. So then what I will do here, just I will use the concept of L dot acquire. So if I want to if I want to use the concept of lock, first I have to create what? I have to create lock object. So just I am going to take L lock object I am going to create. Now can I implement the concept of synchronization by using lock? Yes. For that, I want to use the concept of, what is that? Lock concept. I want to acquire the lock first. That means what? To execute this, this for loop, only one has to enter at a time. For example, I am taking. So that what I have to write? L dot acquire. So whatever the thread that is going to reach here first, that will acquire the lock. Only that thread will execute first. Okay, after completing the task, what I have to apply? I have to apply release. If you are not going to release the lock, automatically what happens? You are going to get that particular for loop cannot be executed by any other threads. Okay, observe carefully here. Just I am going to write two statements. One is acquire, another one is release. Then here you have to understand clearly that whatever the region or whatever the code that is written in between acquire and release, that can be executed only by one thread. Now just I will demonstrate this program for you. So T1 dot start, automatically it will go to where what is the target of this T1? Show. So it will jump to show and it is going to acquire the lock. That means what? First, what is going to be executed? Shiva is going to be executed. Thread Shiva is going to execute. Just I will keep here some sleep time so that you can understand clear output. So here I am going to import time module also. Already we know about this time module. Just I will sleep. A thread want to sleep for 2 seconds, or I will make only 1 second. Okay, right. Observe carefully now. So see, thread Shiva, it is printing. Slowly it is printing. Next what? After completing thread Shiva only, thread RAM is going to print it. Okay, this has to be understood by you because one at a time is going to enter into that particular loop. Okay. After that, it is going to complete the task. T1 is completed its task and T2 is also completing its task. Okay, right. Now, after release here, what we have to observe here? Acquire the lock, release the lock. And whatever the code that is written in between this acquire and release, that will be executed only by one thread. See, observe carefully. Here, this will be executed by whom? Only one thread at a time. Now, here, if I am not going to write, let us take, if I am not going to write release. If I am not going to write release, what happens? One lock is one particular thread enters here, T1 enters here to execute this one, and it is not releasing the lock. Its task is completed, it's not releasing the last lock. Then T2 can enter into this particular code or no, it cannot enter because already lock is not released by T1. Now let us observe this one once. So see, thread Shiva T1 entered and executing its task. So now see, it's so on waiting because what happens here? The thread is not releasing its lock. So what I have to do? I have to stop this program physically. 1 minute. Here what I have to do? Here I have to stop this one manually because lock is not released here. Okay. This is the concept of a lock. Now I want to show you one more case so that you will get a clear idea on this lock concept. So one more application I will take. That means one more program I will take here. So observe carefully here. So one thing what we have to observe here, lock is going to be applied on. Lock is going to apply on what? Lock is going to apply on a thread is going to apply lock. Okay, thread is going to acquire lock, thread is going to release the lock. Then only synchronization concept will be applicable. If there is no concept of acquiring lock and releasing lock, what will be the output of this program? Can I expect that? I can't expect. See, inconsistent output we are going to get here. Okay, right. So now see, completed program is completed here. Now observe carefully here. Now I am going to write one more program where we will get a clear idea on this one, on this lock. From which module? Threading module. What I have to do? I have to import all. Okay, so that I have to write import star. I have to write. Okay, I have to use the concept of import star. Import star means what? Import star means importing all. And I also want to show you the timings here. Just I will use a time module. Okay, right. Now just I want to create a 2 threads and 1 lock. 2 threads and 1 lock. So just I will name the lock as thread lock. Clearly, to make you understand, I am making the lock name as thread lock, and I'm going to create that lock object. Now see here. Now what I want to do, I want to create 2 threads. The name of first thread is, we can write T1 and T2, but I want to make you clear. And here generally thread 1 has to be which type? Thread 1 has to be thread type. But here I am going to write by using a class. I want to implement the concept of threads by using a class. So I'm going to write my thread. My thread class name is what? My thread. And here it is going to extend what? Thread class. So automatically we can understand what? We can understand that my thread is what? A class that is extending thread class, so that whatever the object that is created for this my thread will be thread. Okay, let us consider. I will not make it complex. First I will write thread here. The meaning of this one is what? The meaning of this one is, here I will write some target. Just I'm going to take a small example. Here if I write show, what is the meaning of this one? Here for this thread, that means what? For the thread constructor, I am passing what? Some target, so that it can understand what it has to execute. But now I am going to take what? I am going to take my thread, so that just I will remove this one. I will write first complete this class. So what here I have to write? First compulsory, I have to use the concept of constructor. So define init. Already we know about this constructor concept. So I want to pass 3 parameters for this one. So self is normal. Next I want to pass id of a thread. Otherwise I will take clearly thread id. Just I will take thread id, and I want to pass name of the thread, and I want to pass counting. Okay, just I will take counter. Okay, otherwise here no need of taking this counter. Just I will take name and id. Just to print name and id, I am going to use this. So compulsory, one point we have to understand. What is that means? Whenever one thread is going to be created, its constructor is going to be called. So as here I am going to create my thread type, this constructor will be called. And if we want to create a thread by using a thread class, compulsory what we have to do, we have to call the constructor of thread class. It is compulsory, as we know that. Okay, so that I am calling the thread class constructor also. Now here what I will do, just I am going to initialize self dot thread id. I have written what? Thread id equal to thread id. I am going to write. I am going to write thread id. After that, I want to initialize what? I want to initialize the name also. Self dot name equal to name. This is nothing but thread name. You can take it anyway. Right. Now here by default, if I'm not passing anything to a thread, that means if I'm not passing any target to a thread, then automatically it will go to where? It will search for a run method. So that I am going to write run method. and this run method is what? Instance method, so that I have to write what? Self. Now what I am going to write here means, just I want to print the name of a thread. Just I want to print what? I want to print the name of a thread, and I want to show the time when it is going to print. Okay, right. Just I'm going to write what? Print of. Here I am going to apply what? Which thread is going to start? I want to write here. So starting, which thread it is going to start? I want to write. Just I want to concatenate it. So self dot name. So what happens here? I want to tell that some thread is going to be started here, and I want to make what? I want to run the same thread 3 times. So that I'm going to write what? For loop. For I in, that means I want to give some execution for this one. For that I'm going to write some for loop, and here what I will do, I will sleep for some time. The thread want to sleep for some time. For example, I will make it to sleep for some time. So t dot sleep, time dot sleep I have to write here, so that whatever the thread that is going to execute this run method will sleep for 2 seconds here. After that, it is going to print what? I want to print, observe carefully here, I want to print the name and here I want to print a name. So, and I want to print the time also. Already we know that if I use the concept of time dot time, we are going to get the time. Okay, just I will show you that. So here I have to write this one as in double quotes, and dot format I have to use, format method I have to use. And here what I have to write? I have to use, for first one I want to write a name, so that I'm going to use self dot name. I'm going to, so that it is going to print name. It is going to print what? Name. After that, for second parameter, for this I want to replace with time. So just I will write time dot time. Okay, time dot time, so that you can see the time. So just here you are going to see what? Only in seconds you are going to see, seconds and milliseconds. So but I want to see according to our normal time, that is what? Month, date, day and date. If you want to see, I will change it. First I want to show you what it is going to print, later I will modify this one. Okay, now observe here what happens here. We are going to use we are going to print, that's it. Now this is the task that every thread has to execute in run method. So that I want to do what? First I want to use the concept of locking. So for that I have to use lock thread. What is the name of the lock here? Thread lock. So I'm going to use what? Thread lock equal to, thread lock dot acquire. So whatever the thread that is going to arrive first here is going to acquire this lock. After completing the task, what it is going to do? It is going to release the lock. So thread lock dot release. Okay, right. So this is the thing we have to observe. Now what I will do, just I am going to create two threads. I am going to create. What is the name of the class? My thread. Because where run method is there in the my thread. So that I have to create object of my thread only. Right now, while creating this one, observe carefully, while creating this thread one, this constructor will be called. How many parameters are there in this constructor? Two are there, thread ID and name. So thread ID is one, and the name I am going to pass as Shiva I am going to pass. Okay, now I want to create second thread. First thread name is what? Shiva I am going to place. I want to place thread 2 name as, for example, thread 2, and the ID for that one is 2, and the name of that thread is, I want to name it as Ram. I have created two threads. Okay, one is thread 1, thread 2, and the name I am going to keep it as what? Shiva and Ram, for example. Now observe here, I want to start thread 1. Thread 1 I am going to start. Thread 1 dot start I am going to write. At the same time I am going to start thread 2 also. Two threads are started here. What is the task of thread 1? Thread 1 dot start means, is there any target that I have given here? No. So automatically it will go to where? Run only. Thread 2 also it will go to run only. So both are going to run. Both are going to run method in a my thread. So here what happens? This code is what? It is a synchronized. The lock is acquired by a thread. Whatever the thread that is going to reach by a that reaches this run method first, it will acquire the lock. and other thread has to wait. Okay. And now one more point I want to tell. One more point I have to apply here. That is, while thread 1 and thread 2 are going to execute this one, main thread will execute this one. There is no synchronization for that one. For that, what I will do means I will apply join method. Already we know how we are going to apply join method. If I write thread 1 dot join, and I will write here thread 2 dot join also. What I will do, thread 2 dot join. Then what happens? Your main thread will wait. Your main thread will wait until thread 1 and thread 2 completion. That means what? Until thread 1 and thread 2 executes this run method, your main thread will not execute anything. Just I will write some ending main thread. Just I will write one statement, ending main thread. I will write here. Okay. Now see this program carefully. What I have written? Just I have written a code. The small code I have written. This is the code. This is the code I have written inside a acquire and release. That means this code can be executed by how many threads at a time? So this code can be executed only by one thread at a time. Reason is this code is written in between a acquire and release. And this section can be called as what? Critical section, or this code can be called as critical code. If I am saying some code as a critical code, it can be executed only by one thread at a time. So in my program, how many threads I have created? I have created two threads. So one thread name is what? Thread 1. Other thread name is what? Thread 2. And both threads I'm going to start here. And I created one log. Remember one thing, before going to apply the acquire and release. Acquire and release are present in which class? Log class only. So compulsory we have to create an object of that particular type. So lock object is created here. The name of that lock object is what? Thread lock. So that thread lock is created and two threads are created, and I'm passing two parameters, and I'm starting thread 1 and thread 2. And this is the scenario of what? This thread 1 and thread 2 are going to apply, on thread 1 and thread 2 I'm applying a join method. That means what? Oh, so which thread is executing these two statements? Main thread. So main thread can understand that. So I have to wait until thread 1 is completed, until thread 2 completion. I have to wait. After only it is going to execute this statement. Okay, right. So what happens? Step by step, I will execute here. So whenever the statement is going to execute, what happens? Thread 1 is going to be created, and these two parameters are passed to here. So thread ID is what? 1. Thread name is what? Shiva, for example. Next, after that, I'm going to call superclass. That is what thread class constructor is compulsory to create a thread. After thread, I'm going to initialize the values. That is what thread ID equal to thread ID, self dot thread ID equal to thread ID, and self dot name equal to name. Okay, completed. Here, just I will print the, what is that? ID also I will print. Okay, just I will print ID also here. So just here I will write self dot, the name of that is what? Thread dot ID. Oh, sorry, thread ID. So here I'm printing, okay, sorry. Okay, initialization is done here. After that, second thread is created. For that also initialization is completed. And now thread 1 dot start. Automatically what happens? Thread 1 is going to start it. At the same time, main thread is going to execute this one also. So both threads are comes here, but first which thread will come to this run method? So thread 1. So thread 1 is going to execute this statement. That means thread 1 is going to acquire the lock. Which lock? Thread lock. The name of the lock is thread lock here. So it's going to acquire that lock, and it's going to execute what? Starting. The name is what here? Self dot name is nothing but first thread. Thread 1 is name is what? Shiva will be printed here, and it will sleep for 2 seconds, and it will execute what? ID, name, and time. Okay, and after completing 3 times, it is going to release the lock. So if it releases the lock, automatically thread 2 is waiting for to enter into this particular code. So it will acquire the lock, and it will execute this one, and it releases the lock. If any thread is waiting outside, it will acquire the lock. But here in our code, only 2 threads are there, so that the code will be ended after thread 2 execute this one. So after executing thread 2, automatically your main thread is going to execute. After completion of thread 1 and thread 2 only, main thread has to execute. Now let us see the output of this program. So here we are going to get some error that thread ID is not defined. Let us see some, there may be a spelling mistakes may be there here. So let us observe here where it is. So it is in 21st line and 6th line, 21st line. Okay, this is 21. Here I am passing 1 thread ID. 1 minute. Thread ID is not defined. Line 6. Line 6. Here I am going to take what? Thread ID. Same, all I am using the same code only. Let us see, verify clearly. So why here I am passing? Okay, first I will explain about this one. Why I am writing this line here? Because first thread 1, while creating thread 1, we are coming here. Self will act as what? Thread 1. That means I want to tell thread class that I am creating one object called as thread 1. For that purpose only I am going to use this one. Okay. Anyway, now I want to see the error here. So here what I have created, anyway, define init, okay, self comma, I'm going to write some name comma thread ID, I'm going to write here. Okay, after that I am using thread ID equal to, oh sorry, here I am writing thread. Okay, I will write capital D. Let's see here. First it is executing, Shiva is executing, thread ID is printing, his name is printing here, ID name is printing, and time is printing here. Again, starting RAM is printing, and it is executing something. Okay, just to make you understand, I will change something here. Just I will write here starting colon I will make, and after that, so see here what you can observe here, it is going to give the output in what? Some seconds, some epoch time. Based on the epoch time, it is going to give you what? Some seconds it is going to give. So I don't want to see the seconds, I want to see the exact date, time, and day also I want to see here. For that I have to use one method. Okay, the method is ctime method. What is that? Ctime, which is present in time module only. Time dot ctime. In that I have to pass some what we can say at that time, the seconds I have to pass, so that it is going to give me exact date and time. Now observe here, I am going to, it is going to generate what? Seconds, and it is going to convert that seconds into day time. Okay, observe carefully now. So see, starting Shiva, first thread, so one Shiva ID, and it's going to give what? Clearly time. Why the difference is 2 seconds? Because we told to sleep 2 seconds. So see, 51 completed. Okay, now observe carefully, this has to be understood by you carefully. Reason, as if we understand this lock concept only, we can understand the concept of R lock and semaphore also. So here what is going to be done? Thread 1 and thread 2 started, but first thread 1 is started, so that it has to execute this run method. So while it is executing run method, first statement is what? Thread lock dot acquire. That means to execute this one, to execute this code, T1 is acquiring the lock, so that while it is executing, T2 came to this run and it's entered into run, and it sees what? Thread lock dot acquire. But if it tries to acquire this lock, can it acquire? No, because that lock is already present with thread 1, so it has to wait. After it will enter into waiting state. So what happens? Thread 1 will complete all its tasks, and when it is going to execute this line, automatically what happens? That lock is released. So who is waiting for that lock? Thread 2 is waiting, so it will acquire that lock and it enters. So you can see the output clearly here. So first Shiva entered, it executing it. After completing this statement, it released the lock. After releasing, what happens? Thread 2 is ready to enter into that one, so thread 2 is entered and it's executing its own task. After thread 1 and thread 2 is completed, what happens? Main thread is going to execute. Why main thread is executing after T1 and T2? Thread 1 and thread 2. Reason is, we have written this statement called as thread 1 dot join and thread 2 dot join. That means main thread has to wait until thread 1's completion and thread 2 completion. Then only it will execute remaining code of main. So this is the concept of lock. So this is very important concept we have to understand. So this is a fundamental method. This is a fundamental concept that is going to be used for synchronization concept, that is lock. So here why we are going to use the C time? To see the exact time. And here why we are going to get output as 41, 43, 45? Reason is it takes some 2 seconds here, 2 seconds to sleep, so that it takes 41, 43, 45 and so on. Okay, so this is about lock concept. So next session we are going to see about R lock and semaphore concept, how to implement synchronization by using R lock and semaphore. Thank you.